Yeah. So, I mean, the other topic that keeps coming up in the causal world is DAG, right? Of course, we have had a lot of debates and fights around it. I mean, economists believe that, DAG is useless, but then epidemiologists, they think that, oh, no, it's so useful. I think Julia Pearl and Guido Evans, they had a nice little debate. I mean, we can, leave the links to those debate in the comments. What's your take on that? I mean, I personally believe that yes, of course, DAGs are very useful, but it's also should be used with a lot of caution, right? Just because you have drawn a DAG doesn't mean that you have proved causality. My opinion is that DAG is something that comes after you have proved causality rather than a hypothesis generating mechanism. What's your view on that?
So it depends how you use the tool. As usual, it's not really the tool that is the problem, it's how we use it. And I really like healthy debate. And I'm a trained economist, but I still draw tons of DAG and usually argue you should start there. And what I mean by this is just basically it helps to state your assumption and visually show your assumptions. And I think that is central because you want to be sure you know that you have bad controls, you have stuff that you don't want to include. It's not like in predictive inference when you can throw the features and let the model select. Here you have features that you should not include, for example a collider, and you have to state your assumptions very precisely. So that's why I always start with the DAG, because it's visual, it shows the assumptions. You have these confounders, I include them. We have these unobserved confounders, fixed effects will take care of this. And this is, again, a very hot topic because I just shared this paper that I discovered showing that fixed effects, which is usually the kind of the Swiss Army knife from the econometricians, can create some collider bias issues. So you really, and that's a reason, again, to draw the DAG to be very clear what are the factors that are taken into account by the fixed effects. That's one thing. The other thing, sure, I mean, the A in DAG, I really don't like it, the acyclicity. Why? Because in most of the cases, use cases that I had in my scientific research career, you had simultaneity or reverse causation, which is creates cycles. And then, of course, people might argue, but it's not really simultaneity. If you break down, you have also this nice paper about, it's called something like the importance of the time decomposition in DAG, something like this. And indeed, for example, if you think about COVID, it's lockdowns affect cases, but cases affect lockdowns. And basically, but you can always say, okay, it's cases in t minus 1, which affect lockdown in t, which affect cases in t plus 1. But it depends the t. And the t, sure, you can say it's a second, and then you can argue that it's not instantaneous and you don't have a cycle. But actually, the indices should be based on the granularity of the data, which is basically if you have daily data or weekly data or yearly data, you probably have some simultaneity based on this granularity. So it breaks down the whole acyclicity thing. So long story short, when I use DAG, it's not to solve, to prove anything. It's just to highlight the assumptions of the model. So that's my take on DAG, and often I call them directed graphs, and I drop the A because sometimes I'll allow and I'll even recommend and recognize that you have cycles.
Yeah, I think there's also another graph, which is the single world graphs. I mean, that's also a useful supplement to DAGs, especially if you want to represent, your control and treatment group in the same graph. I think DAG does not do that, but at least SWIGs kind of do that. Right. Yeah, but thanks for weighing in on that.